So let's take a look at the reactions of fatty acid synthesis. Fatty acid synthesis is performed on a multi-protein complex, very large complex, and that complex is called the fatty acid synthase complex. There are multiple cofactors and proteins part of this, but this video is to just simplify the reactions and look at the mechanisms of what's happening. The reaction is a condensation, reduction, dehydration, and reduction series of reactions. These four reactions will occur over and over until we finally form our finalized fatty acid. So to begin, we have what we call the entrance site. This is part of one protein. It's called an acyl carrier protein. The acetyl-CoA that we generated with citrate lyase, cleaving citrate into acetyl-CoA and oxaloacetate will begin the process of fatty acid synthesis. So using this CoA group, this high energy bond, we are going to conjugate the acetyl-CoA onto this thiol, forming a thiol linkage on this sulfur, and that will conserve the energy of this bond. The next step of the reaction is to shift the acetyl group that has now been attached to the fatty acyl synthase enzyme, and we're going to shift it over to the next site, also maintaining a thiol linkage. The entrance site now being available, we will be able to place malonyl-CoA, which recall was the product of the acetyl-CoA carboxylase reaction, and we will be able to add this malonyl-CoA onto this sulfur, forming a thiol linkage. Now this reaction by acetyl-CoA carboxylase added a CO2 and also added ATP, so basically we are charging up this molecule for the subsequent reactions. Now once we have both sites filled on our fatty acid synthase complex, we can now start performing the chemistry. And that chemistry is going to be a condensation reaction, step one, in order to form a bond between this CH2 group and this carbonyl of acetyl-CoA. In doing so, we are going to release CO2 from this reaction and drive this reaction forward. So the result of this condensation reaction is going from a 2-carbon to a 4-carbon intermediate. The next step of the reaction is that we need to begin reducing this structure. Reducing primarily because, recall, fatty acids are long hydrocarbon chains. We have a carboxylic acid on one end of a fatty acid. We have a series of CH2 groups, N being a variable number, and a CH3 methyl group as the omega end of the fatty acid. This N, in biosynthesis of fatty acids through this process, will equal number 14. Because 14, 15, 16, we will be making a C16 saturated fatty acid, which is palmitate. So in order to generate the fully saturated and hydrocarbon chain, we have to begin reducing these groups. So we are going to use our first NADPH in this reaction as a reducing agent, and we are going to reduce this carbonyl into an alcohol. The next step of the reaction is a dehydration reaction. So this bond here we are going to modify by removing water, and by removing water from this we are going to create a double bond at this point. Now once we have a double bond, the fatty acid we will be making is fully saturated, so we have to reduce this double bond. And we will be using our second NADPH molecule to reduce this double bond to form our hydrocarbon chain. Now at this point we have completed the formation of a very small fatty acid. If you notice, we have a carbonyl. If we remove this from the fatty acid synthase complex, we can put an oxygen here because water will remove this. There's our carboxylic acid and our hydrocarbon chain. So after this first round of condensation, reduction, dehydration, reduction, we have formed a C4 fatty acid. The next step is to shift the growing chain of fatty acid over onto the chain for the next reaction. Once we move the C4 carbon molecule over, now we can put malonyl-CoA into the entrance site and once again perform the same condensation reaction that we saw in the first step. This results in the addition of another 2 carbons. 1, 2, 3, 4, 5, 6. We then go through our reduction, dehydration, reduction reaction to modify this group, this carbonyl, into the hydrocarbon to form the fatty acid chain. So now we have at this point, we have a C6 saturated fatty acid. We do this over and over again until we finally achieve our C16 palmitate. Now once we have our carbonyl with our carbon chain, C16 fully grown, fully matured, then we need to remove it from the fatty acid synthase complex, and we are going to use a thiolase enzyme with the addition of coenzyme A. So this will essentially generate our palmitate with our coenzyme A attached. And here is our final product. Now once we have this structure in the hepatocyte from fatty acid synthesis, now we need to form a triglyceride. So we are going to take this structure and make a triglyceride, which again will be a glycerol backbone with 3 fatty acids attached in an ester linkage to the backbone triglyceride. Once we have this, we'll be able to form our lipoprotein carrier to package up all the lipoprotein, all the triglycerides and cholesterol esters, and then we'll be able to safely secrete this into the blood for circulation to extrahepatic tissues.